Welcome to Computer Vision Decoded, where we help you make sense of the quickly evolving world of computer vision. Today, we have a special guest, Pierre Moulon. He's a research scientist in computer vision and also the founder of OpenMVG. And in preparation for this episode, I read Pierre's latest article where he has a 10-year retrospect on OpenMVG. I'll make sure I link that in the show notes for this episode so you can read that and have a little perspective about where he's coming from. So there's lots that we're going to learn from his 10 years of experience in this open source project. There should be something in here for everyone. So if you've used an open source library or if you just want to know what they are, there's something you're going to learn here. We're also going to talk a little bit about what multi-view geometry is. And always, we'll be joined by Jared Heinley, my co-host, who will help us make sense of some of these terms in computer vision that might be new to you. So without further ado, let's jump into this episode. Welcome, Jared, and welcome, Pierre, to Computer Vision Decoded. I'm really excited to have you as a guest, Pierre, because you have a lot of experience in 3D reconstruction and structure for motion in the computer vision space, and you've done something special for the community that you did a decade ago. So before we get started, just want to welcome you too. And Pierre, can you just give us a little bit of a background about who you are and what got you into computer vision?
Yeah, thank you for having me here. About me. I started to just be interested about computer vision when I was a teenager, first playing video games and try to understand the world and represent it in computer games. And I saw that you need to design, to do level design, you need to do boxes side by side to put polygons everywhere to represent the world with low polygon. And I was thinking, why we can't do the same by just using pictures? So I was looking around, found a company that was doing that with a lot of manual operation. And I said, I want to work here later, and I want to do that automatically without having to click points between pictures to link corresponding points. So I pursue a technical diploma first in computer vision, then engineering school in computer vision, then start to work in some startups doing 3D reconstruction and generation of panorama from multiple images. And then still interested by research, I move in another company working for large-scale image matching and say, okay, now I feel like I have a lot of components together, but I would like to put all of this together to do 3D reconstruction. So I pursue a PhD, worked during this for 3 years, created OpenMVG at this time, started to do open source a bit before. And since then, I'm working in many startups related to 3D reconstruction from images. And I want to make this available for everyone and showing how great computer vision could be for usage for everyone.
All right.
That's
awesome.
Awesome.
A great background.
Yeah, that's awesome. I didn't even hear about computer vision prior to grad school. You know, similarly, I had, computer games, got into graphics and things, and then once I went to grad school, then realized, oh, wow, there's this whole field of computer vision. So that's a cool, it's a cool story to hear that, you were looking for that. You were looking for a way to take photos and extract 3D information from them. So awesome.
So you're telling me as a non-computer vision scientist, I should be still telling my kids, yeah, go play video games because I might be inspiring them to become an engineer with computer vision. I like that analogy. We're going to stick with that.
I think you learn a lot about like how you simulate the 3D world. So it's like you are somewhere in space, you need to protect the world on the camera, show it to the user. Mm-hmm. So you are learning a lot about 3D projection on the 2D plane. Basically a pinhole camera, about you have some point in space, you want to move them as you are moving along. So I think it's a good introduction about what's going to happen if you have a camera later on.
Yeah, and a little off topic, but I do know we have a PlayStation 5 and it came this Matrix Reawakens demo, and they show you the tech behind it. Was it 40 million polygons rendered all at once in a screen, and got my kids thinking, wow, this is really neat how they make this. And so, yeah, it's not. I like that you came from that inspired and then decided to make something more out of it. And so you mentioned OpenMVG, and that's what we're here to talk about. That is something that you've been working on for a long time. Can you just give, for the people who've never heard about it, and I've been asking people about it lately, have you used it? And there's a surprising amount of people that have heard about it but don't really know what it is. can you give me that kind of elevator pitch, just top level? What is OpenMVG without getting into any specific detail?
Yeah, sure. So OpenMVG stands for Open Multiple View Geometry. And the goal of the library is to provide a set of tools to the community to do 3D reconstruction from images. So meaning that I want enable anyone to have a sequence of image and to be able to find position of those images in space and a point cloud. And to do this, you need a lot of steps and algorithms to run through. And OpenMVG is providing some implementation for all of them with many state-of-the-art implementations. So you can see this as a kind of a lot of bricks that you can match together to do 3D reconstruction. There is some already existing pipeline in OpenMVG that you can tweak and to obtain directly results. And after, if you are more interested, all those algorithms are here, and you can just play with them and customize them if you want to make something bigger.
Okay.
So the goal is to share knowledge about computer vision with easy-to-read implementation of state-of-the-art algorithm. If possible, have multiple implementation of the same problem to show that one thing can be done in multiple ways with pros and cons every time. And after have those algorithms plugged into pipeline, so you can easily tweak and see what is the results at the end if you use solution A or solution B. So it's to ease reproducibility.
Okay, so that makes sense to me. Hopefully that makes sense to our listeners. And then, so you said this is an open source project. What was the importance when you decided to create this project? Why did you go the open source route as opposed to that point saying, I'm going to make this into software I can sell, I can monetize, I can make money off of?
Yeah. So I think for me, just because I wanted to share and make things easily accessible to everyone. And somehow 10 years ago, not a lot was accessible. Or some of it was accessible, but it was all in different libraries with different license. And some of them, the license were proprietary. So it's like you can't really use this or else it's going to contaminate your code. So my goal was to make something that is patent-free and free to use for everyone, either for research or for companies. My first intent was I want to share knowledge, make this available for everyone, and hopefully some people will pick up and do something bigger with it.
Okay. So Jared, how's that line up with your timeline? About a decade ago, was that before, after you were doing your PhD? Was this software early on that you heard about or used early on?
Yeah. So a decade ago, I was in the middle of my PhD at that time. Now, in my research lab, we had our own, internal computer vision engine, 3D reconstruction engine that we were using and building upon. So when I was doing my work with structure for motion and 3D reconstruction, I was using that. We also and so at that time, I wasn't aware of OpenMVG. I had my pipeline in front of me, and so that's the one I was working on and maintaining. So. It was later, once I had graduated, that's when I realized, oh, wait, there's some other packages out there that are doing similar things. But at the time, missed out on it.
Like I said, importance too, you graduated, no longer part of a school program. You might need to open up your possibilities to other libraries, which ones maybe have different licensing, things like that. Very interesting. Okay, so then in general, then a question to you guys is, Pierre, you took this first. What is that in the general? What has been the impact or the importance of having these open source libraries for the computer vision community? It sounds like to me, as I use different software that's commercialized, and a lot of times they'll show in some sort of console what's happening in the back end. A lot of times you'll see little references to some open source libraries. Is that something that pretty much all of you are accessing and using, or is this a great value? How does that have an impact on the computer vision community?
Yeah. I think impact can be two ways. So the first of possibility is awareness. So it's just like helping the community to know there is some implementation there. There is some unit tests for it. There is some results with it. So you can try to trust this, use it if you want, or get inspiration from it. Try to have a model that you can build upon. And the second one is just code is there, available for everyone, ready to be picked up. There is other big libraries like OpenCV, Seagal, It's all great project. It's just like easy to bootstrap from, try to get knowledge from them, either from their documentation, from their code, or from just questions on GitHub. So I think the other impact is the community aspect. Is like the library itself is knowledge, but after like you reach also a community of people using it, and also welcome to share their knowledge to help you accomplish your goal. So I think an objective are twofold. It's like knowledge, and after like the community part of it, it's like you can go inside something that is bigger than just knowledge.
That knowledge is important. I know, a lot of times during grad school, or if you're writing a research paper, it's there are times when some research papers may not provide their code, or it's like, what is the reference implementations? Like I may have a paper that I'm reading that describes, the details of an algorithm, but then having that algorithm implemented somewhere, that you can actually run and refer to and see the code, is incredibly helpful, and seeing a system as a whole. So an entire 3D reconstruction pipeline is made up of a bunch of different algorithms that are all combined together to run different stages of that reconstruction process. And so having all of that code sort of in one place is really, really helpful. Just because you can understand the context, but then it makes it a lot easier to build upon. Coming back again to research, it's when when a lot of times when research is happening, it's like you're not building everything from scratch. It's like you're building on top of existing work, and so when, like during my PhD, it's like, okay, I was working on duplicate and repetitive structure correction. And so it's there, I'm just working on one module that's like a post-process operation on top of structure for motion. So it's like you already need a full 3D reconstruction system there. And then you're adding on this one new module that then you can publish papers about and do research on. And so having, reference implementations that are available and open source and high quality it just enables research, because you can, build upon, the shoulders of others. Having that code there just, helps people focus on the new novel stuff and leverage those existing implementations.
All right. Well, so would you say that for an open source library, finding one that maybe there may be some that are useful but don't have quite as much of a community behind it? Do you find the community aspect around these libraries, these projects, could be even more like you maybe opt for one just because, hey, if I run into questions, I can rely on this community, versus you see some interesting thing on GitHub and there's nothing on the discussion board, there's nothing, no questions, maybe a couple of answers, and you're like, is that something that you guys think, is that something you think about when you're going to use a library or a project like this?
Yeah, I think like when you look to open source, like it's all about user and user value proposition. So you could say, okay, a project is just, there is no activity in this open source project, but it provides all the user value that people want. So like the proposition is there, you use the code, you do what you want. It's mostly the case for like mostly JavaScript modules that you can find online, like to view image on sliders or things like that. So like it's there is nothing much more to do better. And after there is other projects that somehow is like you need to keep improvements. The project is getting a lot of iterations, and after you reach a kind of MVP stage, like a minimum viable product, where you say, okay, now I have something that I'm okay, people can start to build from, like you say, okay, it's strong shoulders, I can build something on top of it. And I think at this point, when you reach the MVP and people start to get interested because they have awareness from themselves, from other researchers, you can really build those communities about, okay, I ask questions, people are taking time to answer to me, I feel welcome, and now maybe I will contribute back to this project because I feel like I was really welcome, I learned a lot, so maybe I'm more open to contribute back to help others, or just to help the open source project by itself.
Okay.
Yeah, and that's a cool, it's a key distinction, like you were saying about like if this is a small, a few lines of code, a very, very small module, okay, yeah, maybe it's not maybe there's not a lot of active contributions because the code just works as is. But then, yeah, having these big, complex systems where it does take some expert level knowledge to understand how to stitch everything together, how to run everything, that community is nice, because then it's been tried and tested and an easy been made easy enough to use by, a large community of people. And so, if someone ran into a documentation issue or a testing issue or a configuration issue, hopefully there's a greater chance that people will have, encountered that, fixed it, and pushed those changes.
Yeah, for me, one of the test of time for OpenMVG that I'm really proud of is somehow one day I saw a paper coming out where they made a 3D reconstruction of San Francisco from images, where they cluster everything by chunk with GPS information, and they use OpenMVG to do it all, like the entire city of San Francisco, like millions of images. And somehow I was not aware of this work. No one tried to ask me questions about it. And I was very proud about it because it's like the project was empowering people because the user value proposition was here. Like they came to the project, tried to use it, maybe do some small tweak like for chunks and stuff like that. But somehow it's like they made it by themselves, made a paper, got what they wanted, cited the project to say thank you. And it's all what it's about, because somehow it's like if someone wants to do the same, they know which tools they can use, which method can be used because it's described in the paper. And it's all what matters to build the community. It's like having this feedback loop about, I was able to make this great thing, I say thank you, and I explain others how I did it.
That's awesome. That's great validation.
All right. Yeah. So I'm going to come back to this topic about community a little later on as we talk more about your journey of 10 years of building this OpenMVG. And so when I say OpenMVG, there is 3 letters in there that stand for something, multi-view geometry. And so I wanted to dive a little bit more into that part of the aspect for talk about your journey of building this now. But just, again, you give us a high level what this software is. Can we just a little bit, to use the term from our podcast name, can you decode what multi-view geometry is? And just talk about that as a process in 3D reconstruction as opposed to in your software in general. But just what's happening there, Pierre, when you're doing what is multi-view geometry? Because I think of structure from motion, I think of photogrammetry, I hear those terms. People might not kind of understand that one specific term within that 3D reconstruction pipeline.
Yeah. So multiple view geometry is a bunch of methods that help you to solve structure from motion. So structure from motion, there is 2 words inside structure. So meaning you want to find a structure of the world, meaning, for example, point cloud, from motion of the user or motion of the camera. So meaning you need multiple images to be able to find corresponding point between those images and find a way to triangulate those points to create the structure of the world. So to do that, you need first to establish correspondences between those images. So saying, for example, I have the same point in my background between multiple image, and now I can try to find a relative pose between those images and triangulate those observations. So the entire energy function that you want to minimize to solve this problem somehow is a reprojection error, meaning I create the 3D points that I know I can reproject in multiple images, and I want to minimize the reprojection error in this image between the observation of those points I have in this image. So key points in this image could be used by SIFT. After you need to match those key points, so you need to do nearest neighbor matching, and after you have a list of key points together, those key points does not have sense yet in a geometric space. They have just a sense of matching in photometric space, so meaning those patches look alike. And now you need to bring some geometry in to do multiple view geometry to find corresponding points that make sense from a geometry level. And to do that, you can use fundamental metrics or essential metrics or homography metrics. Basically, you want to find if 2 points can lie on the same plane, given the camera geometry that you are trying to estimate. And to do so, you need to select some points randomly, try to estimate these fundamental metrics, try to see if this model is fitting your observations. So it's called basically ransack. And once you filter those observations, now you can try to triangulate those observations.
Okay.
So it's the start of the pipeline. You do that for a bunch of pair of image. And after you want to position all those images in 3D. And it's an algorithm. So meaning there is various ways to achieve it. Meaning you can do it in an incremental way, or sequential way. So you start from 2 images and you aggregate 1 image at a time. Or you can say, I want to do it hierarchically. So meaning I'm going to take 10 images, make a first reconstruction. I'm going to make another group of 10 images and after merge them. So I merge groups as I go along. Or you can say, I want to solve this problem globally. So meaning you're going to take all your estimate together, a kind of graph, and you want to find directly all the camera poses at the same time. And this last problem is called motion averaging for structure from motion. And maybe I will stop here because I say too much and let Jared comment on it too.
Oh, I was gonna say no. I mean, yeah, you dove in there and uncovered lots of topics. I'm just gonna echo back what I heard you say at the beginning. Just saying, multi-view geometry, is at the highest level. Recovering the 3D geometry, the 3D points, the 3D shape, the 3D information of a scene using multiple views, so multiple images. So images that were captured at different positions, different angles within that scene. So you have multiple observations of this geometry, of these points from different angles. And then there's a whole host of, different algorithms that can be used and employed that fall under this bucket of multiple view geometry that then can be used to, recover that 3D structure, that 3D camera motion.
Okay, so then within within OpenMVG, you said there's different methods in which you can say a sequential versus global. Imagine this feature trying to triangulate surfaces. That's one of the features, or you could say one of the benefits of OpenMVG is you can tweak those. You can choose different options and figure out which one works perhaps best. Or am I off track there?
Yeah, that's as Jared said, OpenMVGs want to propose a pipeline, so meaning there is a multiple chain element together, and each breaks in OpenMVG, we contribute libraries as a module. So meaning, for example, we have one small library to do image matching, so people can come there, see 2 or 3 implementations, and eventually add the ones they want. Mm-hmm. We have a multiple view geometry module where we show how to compute fundamental metrics, essential metrics, homography metrics, absolute pose estimation, also known as camera resection. And after, here it's multiple view geometry solvers that you can use to do estimates. And after, you have to be robust to noise. So meaning when you have image correspondences, you can have noise. So you need to deal with this noise. And basically, there is a method called ransack that can be used. Or there is also other methods that we are using in OpenMVG called a contrario ransack that I can speak later if you want. So try to be noise adaptive. And after, once you have those kind of multiple view geometry solvers, you want to go higher and do really the structure from motion. So aggregating all together. So you need to triangulate bumps. So you need triangulation function. You can do it in multiple ways from 2 images, 3 images, n images. And after, at one point, you're going to need to minimize some nonlinear functions, like the reprojection error of your system, and you're going to need to do bundle adjustment. Bundle adjustment is quite heavy in terms of computations. So there is some nice trick to do with bundle adjustments. And luckily, we can leverage another great open source project called Ceres Solver to do that we are using in OpenMVG. So you see at the end, feedback loop is coming. You can't do it all by yourself. So if one great project is here, you are using it and you are able to do more.
Okay. All right. There's a lot of information there. It makes sense to me. I spent a lot of time talking to people like Jared and you to understand that. But, I also just suggest people who want to learn that go type in OpenMVG. There's some great resources on the GitHub page. There's also great resources outside the GitHub page. That's the great thing about your community. They've talked about it. It looks like there's some presentations you can even download that people have created, kind of showing those different modules and what they're doing more visually than that description. So very interesting. So you have this very flexible set of modules that you can plug in where you need it. You don't need the whole stack. Maybe you just need a portion of it, which I find quite interesting. Very helpful if you're starting something off the ground from scratch and you just need parts plugged in. So that kind of comes down to then you're young, you're getting your PhD, and that's when you started building this OpenMVG. That's a lot of work to take on to create something like this, because as opposed to as you just said, you have all these different modules. You're not taking someone else's open source project and making it your own. You're building this all from scratch, I assume. So is that your biggest upfront challenge to starting this project? Was this the sheer amount that needed to be generated and choices you had to make? Technically, is that your biggest challenge?
Yeah, it's a big challenge because somehow it's like you start from A, you say, okay, I'm going to have nothing or maybe something I can use, and you want to go to B. So it's like your North Star. And after there is multiple possibilities to go there. And somehow I set a big constraint at the start. I say I want a permissive project. So meaning everyone could use the stuff I'm doing. It should be free of patent and free of contaminating license. So meaning that if a great solution is here, like for example, SIFT that was patented at this time, you need to find a replacement to propose to your community. And if you want a replacement, you want a solution that is working maybe as good or just a little bit less good, because you don't want something crappy for your community. So yeah, sometimes it's a lot of work. It's also trial and error. So sometimes you go along one path and you say, oh, maybe I can do this better. So you go back and change something. And it happened 2 or 3 times when I was doing OpenMVG, when I say, hey, now it's a good time to stop and to do some refactoring. And one of the things I'm the most proud about the project is the structure from motion database somehow that we are using. So it's one concept we are using where you can store the observations, the camera poses, the intrinsic of the images. So somehow it's all you need every time you want to solve some structure for motion steps. And having this at a single place, be able to load this on and save it on disk in JSON, in binary format, or XML to be very helping others to just do what they want with the language they want. And it was really a key element because when we designed the project, and having this was just a key factor in productivity. Every time we were able to reuse the same module based on the same high-level hierarchy and just boost our speed when we were developing.
Nice. Yeah, so I'm sure there's a lot of upfront. I just think of what I see Jared do right now. You know, he's building. If we build something new from scratch, there's a lot of these upfront architecture choices that you have to make, or how whatever you work on at the start or earlier on may affect everything else down the line. So you try to make sure you stay building something elegant that will be flexible as you move along in your pipeline building. I see that a lot. That's probably a word of wisdom Jared would give people. You know, it's almost don't rush into just coding. Think, spend less time coding, more time thinking about how you wanted to build this project.
Yeah, I mean, and it ties to also sort of into the, you know, sort of research and software development, you know, life cycle. You know, where it's like, you know, when you're starting out, you know, maybe you have an idea of the method that you're implementing, and so I say you're a little more research focused, and so you're trying some things, seeing which works, you know, and then once you have that idea of like, okay, yeah, this is the way that I actually want it to work, going back, doing that phase of refactoring and saying, okay, now that I've got this method that I know I want to use, how can I best fit it into the overarching, you know, picture of that module or that pipeline that gets me from A to B. Mm-hmm. You know, so hearing you talk, Pierre, just about, you know, trying, you know, going down a path and realize, okay, now's a stop, a place to stop, go back, refactor. Yeah, I've been there many times.
Yeah, also it's a learning path. So it's like somewhere like I was alone in some part of the journey. Sometimes other contributors were with me, and I was really glad to just collaborate and try to find something smarter with others. Because often you have bias, like you go in your own direction, and like. Yeah, sometimes you just say, okay, I'm going to pause a little bit, try to understand, am I doing the right thing? And often one way to circle that would be to be more like test-driven development. So like you write first about how you think things going to work. So like the kind of API or language you would like to use at the end. And after you trace back to say, okay, now let me try to implement this. And often, like when we do research, you also need engineering skills. So meaning that being good at mathematics is not the only thing you need. So it's like you need to find a way to do efficient thing on your machine. And sometimes you need help from others to find the best engineering way to solve a given problem. So that's why here also open source is very interesting, because someone can look to your code and just tweak it a little bit and just make it more efficient because he saw it from a different perspective, and provide something back to the community.
Yeah, I would say I've noticed that on GitHub on a few projects that I've been using, where someone they'll merge some new changes in from a community member who they didn't necessarily make any improvements to an output or to functionality, but you notice that they made the code much shorter and elegant. So perhaps someone said, you guys took the most circuitous route to get to what you're trying to do here. Here's a better way to implement this. And so I've seen some of those fixes or code changes, which is just reduce the complexity. And it's very interesting to see that someone might just have a better programming skills, but they don't know how perhaps whatever problem solve technology works as well. They just know, okay, they didn't know how to code that to perhaps their best ability.
And often people can add everywhere. Like it could be code, it could be documentation. Like if you speak about community, like having a nice documentation is really a must-have. So it's like if people can just add the visibility of a project, just drive awareness, everything is helpful somehow. So it's like you don't need really to be a coder to really do open source.
Right. So so now you've built something that you have out there that you're proud to talk about. I'm assuming it's not like the Field of Dreams movie where you build it and they will come. People just show up and start using it. A non-technical question then is, coming back to community, what did you do to build a community, to build awareness, to get people on there using it? Did people just find it because of the lack of perhaps 3D reconstruction tools on GitHub? Or I think it was GitHub where you probably were originally hosting it, or wherever you hosted it. Or was it you going to conferences, shouting off the rooftops, just getting, the community noticing it?
Yeah. I think it's something you realize, like when you are head first in your project, and after you realize, okay, where do I want to go? How am I going to build a community? And it's not going to happen if you stay at your desk. So it's the same thing that is happening at work. It's like somehow you need to build your branding, and it's not happening if you're not making connection. So connection can be built two ways. People are coming to you or you go to them. So one way is to go to conferences, speak about your work. So it's what I did with some paper I did. And every time I was saying, hey, my paper is here, I presented my poster. And every time I was saying, hey, by the way, this thing is implemented in OpenMVG, feel free to use it. So I was trying to drive awareness by myself, going to communities, be approved by the community that this work is relevant. And the other way is to be welcomed by others. So I was really lucky in 2015 to be invited to a SFN workshop in CVPR, where I was able to speak along some others, structure from motion software from this time, like a CRS solver from Google, CodeMap from ETH Zurich. Kitware also got a one package at this time. So it was very nice for me to just be in front of everyone interested in structure from motion at the same time, be able to speak along my peers, and also build connection with my peer at the same time, because without this, I would not have been to just say, hey, I'm with the guys that develop all those technologies, sitting at the same place, and just speaking about what we do. So it's like, connections are two ways. Like somehow you can't make it happen all by yourself. Hopefully, or luckily, you will have others be interested in your work and share how great your work is, and provide feedback for you to improve.
Okay. So, Jerry, can you give some perspective then on perhaps where you're finding open source libraries? Are you finding them more at going to CVPR and talking to your peers, or you have a habit or follow some publications of going out and finding perhaps new alternatives, or you just happen to find them when you're researching a problem you're trying to solve? And you're like, well, we'll see what's new out there, or if something I just didn't know about.
Yeah, I mean, you certainly get both. There are the times, if I'm, working on a particular problem, I want to see, hey, is there a reference implementation out there for this? Is there an existing implementation for this very specific problem? And you search for it, and eventually, you might find some code on GitHub, or you might find code on a research page or something like that, and then you can see that that code exists. But a lot of times though, it does, I find things, online, Twitter, LinkedIn, conferences, where the authors, like you said, Pierre, it's like, you've got to get out there and, and talk about your stuff, build some of that community. And so it's people, advocating and saying, hey, I've got some new, method. Here's the source code. Go check it out. And making that easily accessible and easy to use is really nice.
Mm-hmm. One thing I forget to mention was about try to put yourself in the shoe of your user. So one thing I was doing, I like architecture, and I was taking pictures of buildings in France, mostly churches, because there is a nice texture on it. So it's working great with SFM. So I made data sets along the weeks, and from time to time, I was just making a post on LinkedIn about, hey, here is the new version of OpenMVG. Here is all the nice reconstruction I made with this toolkit. So it was a way for me to demonstrate it's working. See, there is a results here. It was obtained running this command line, given this amount of images. So sometimes, you need to put yourself in the user perspective and just say, they want to understand, is it really working? What can I achieve with this? So you need to work on demonstrating this, and it's taking some time. One nice way is just try to put yourself in a kind of customer of your project and try to understand what you can do with it. Pushing the limits, adding more images, see what happens, and make something bigger.
That's wise advice for any entrepreneur or anyone creating a product, right? Be your own customer, and then also spend time with your customers. See why they might not be using it. Maybe you realize your documentation is lacking for people to know how to get started, or because I guess I always see it's hard too. When you create something, everyone's like, I don't understand why people can't figure it out. It feels very simple to use. Well, if you wrote the whole thing, or you created it, it's gonna be, you'll understand it more than anyone else, because you made every design choice and every product choice there. Versus here's my code, go use it. Here's some documentation. I hope it's enough. I like what you're going around there. Just, you got to get out there. You got to tell people about it and use it yourself. So very interesting. And you guys have a very, this computer vision, I'd say 10 years ago, the field of 3D reconstruction for computer vision was a lot smaller. It felt like, just in the decade I've been in it, I've seen it explode as far as the CVPR attendance and papers and just people talking about it in general, this podcast. So you do, though, have still a quite small targeted audience that you're trying to attract. So you do have that really good ability. So if other people want to create something in the computer vision community, do realize that you don't have to go shout on every rooftop, because there's only so many people in the industry you need to talk to, and they primarily are listening at CVPR, ECCV, all the different conferences. I'm sure you can easily get in the face of people and let them know your project exists. So, all right. So moving us along. So now I want to ask about, so you also had to make, for people, I had this in the opening monologue about going to your GitHub page and reading your 10-year retrospect of building OpenMVG. You had a nice section about making sure that you had an open and permissive code base, and deciding what license to use. I think that's something that I didn't even think about. Well, hey, I'm creating some open source software. There's more than one license you can choose. There's different ways to go about that. Can you talk about that experience that you went through, and how you decided how you want to make this code open for people to use? Is there specific things you're looking for, or you suggest people look for when making that choice?
Yeah, sure. So basically there is so you want to share your work to others, but at the same time you want to protect it. So meaning you don't want people to steal it, or you want to constrain how they could use it. So there is two kind of license. So it's like the permissive one and the non-permissive. So non-permissive are like GPL1, where somehow you want people to use the same kind of license if they are creating a new project using it or contributing to the same model. So it's very successful for applications like Linux or firmware. So meaning that everyone is going to contribute and they have to follow the rules of the project. And after, for permissive license, you can have different kind of permission. So you can say, okay, do whatever you want. So you don't use any license. And after you can have others like MIT or BSD, where you say, at least you should cite my project if you use it and keep this license file to make people aware that you were using this project and eventually this version of this project. And after you can go even further to say, if you contribute to the project, if you fix a bug in the project, I want you to share back this bug, or I want you to just do whatever you want. It's not a big deal. And it's where I was going with OpenMVG. I wanted to share it as much as I can, but somehow it's like if someone is finding a bug, I would most likely to want this bug fixed so it can benefit the entire community. But at the same time, I want OpenMVG here, and if someone wants to get the commercial product from it, I'm totally okay. They just need to say, I'm using OpenMVG. So that's why I choose the NPN license 2, created by Mozilla, because there is this notion about I create this project. If you find a bug, please fix it. But at the same time, if you want to create another project, you can use whatever license you want. And another interesting point of NPN2 license is like it's per file. So meaning like OpenMVG, for example, is having a lot of header files. And if someone is just making a copy-paste of a file to a different project, you can lose the license of the main project. And it's happening often after you don't know where this file is coming from. And you say, most likely it looks like another project I saw somewhere. And that's why I like about NPL2 license. It's going to be in every file. You're going to have this license with eventually a copyright to have more right on it. So it allows to protect your entire project up to the file level with a nice kind of permission about what you control. So still be enabling anyone to do products and try to sell it if they want, or just be in a pure research mode and just sharing knowledge to the community.
Okay. Okay, so that makes sense. So, those are sort of things you need to think about when you're creating this. Is that something you need to think about right off the bat, or can you get kind of building and pushing some code before you need to make that decision? When you're
Yes, somehow you need to think like, so you have your North Star here, B, you start at A, and somehow if you choose the wrong library here, you're going to be stuck because you can't reach your North Star about being permissive. And somehow it would happen if I choose this library to do bundle adjustment or the other one. So luckily I was happy to find that CLS Solver was compatible with the license that was allowing permissive usage. But you can take other projects, like for example, I was trying to use linear programming inside OpenMVG, and there is a lot of framework out there, and most of them have contaminating license, or they have a license that you need to pay to use. So meaning I say, okay, I don't want this, so meaning I need to spend some time to find other existing projects, try to compare them, try to see performance in terms of speed or in terms of accuracy. And after I made a trade-off, I say, okay, I'm going to pick this project because it allows me the best trade-off between speed and accuracy and still enable my project to go further. So it gives a delta in your velocity because somewhere, like you say, now I need to find more time to evaluate everything, to find a solution, learn how to use it right, and now I can be empowered for the future of my project.
Talking about the time commitment it took to do the research, to build the code, maintain your project, this is a huge commitment. This is basically like a second job or a side job. Can you talk about how you go about being funded for this, or do you just do this as volunteer work? I'm thinking of building my own project. How should I be thinking about this? Should I be thinking as this is just something I want to build for the community for my own resume, or I just want to use it? Or should I be looking for some funding? How did you approach that, and any sort of advice you give to other people looking to build a project like this?
Yes, it's a great question. So as you said, it's a big time commitment. So first I did it on my own spare time. So you start, it's evening time, you do some stuff and you say, oh, it's very late now, I'm going to go to bed and say, I'm going to do this again. And after, with my PhD, I found the opportunity to do that with some funding. So somehow I was paid to use my brain to design open source and to work on it. But when my PhD stopped, I said, okay, now I'm without funding. I would still like to pursue and continue this project. So I continue on my spare time. I did some part of OpenMVG with some fundings, so working as a consulting for one or two companies and be able to improve the project. And later on, after it's like where you want to go. So like somehow OpenMVG for me it's my resume. I don't need to share a resume to someone. Somehow it's like OpenCV is on my cards that everyone can know. So it's like open source can be showing your skills to the community. So if you want to invest and show those skills publicly, you can do it. Or else you can say, I was working to this company doing something, but I can't really speak about it. So it's just the spirit about how you want to show your work and your capabilities. And yes, it's a big time commitment. So OpenMVG is my first baby, as I call it. Now I have 2 kids, 2 dogs, and most likely I don't have as much time to just do open source as before. And regarding legality with your employer, so it's something that you can speak about when you are going to be hired. So saying, hey, I like open source, it's part of my life. And if you want my skills, it's most likely because I made open source. So it's a part of me that you want to keep. If you just push it away, I will be most likely a less good engineer or researcher in your company. So don't be shy and just say, if I'm here, it's because of all the things I did before, all the things I'm capable to do. And if you want to keep open source as part of your life, you can find a way to negotiate it with your employers. It could be about you speak loud about which kind of features you want to do, because sometimes it could be similar things. You know, you are working in an expert field. So it's like your hobby and your work are mixing together. So you have to be very upfront about what you would like to do for your open source project and see if there is a conflict with the company. And sometimes it could be a conflict and say, oh, we're going to solve this conflict because we are helping each other at the end. We help the business of the company, we help your open source project, and we contribute something to the community. So it happened for OpenMVG with some of my work experience, where it was like, oh, no, let's stop here. And we decided, oh, let's go further and empower everyone.
That's great. So yeah, I like that you saying being open, transparent with your employer about this. I could see that perhaps you build a project not quite as big or as involved as OpenMVG, but I could see being in university or just out of my degree, and I have time before I have kids, before I have a family, to build something that is a great resume builder. And something that I don't think about is the fact that there's a lot of things that we do and in this industry you can't talk about, right? I work at a company that has an NDA. You want to interview me, but I can't tell you what I'm working on to any degree of specifics. Well, open source is open. It's right there. You can see what I did. You can, it's a great resume builder. That's a great point there.
Every time it could be about user value proposition. So it could be a small open source project with very narrow skill. Like OpenMVG took me 10 years, like with trial and errors. So somehow I'm happy about where I am now. But you can start small and still show a lot of skills or just learn new skills. It's all about learning. So you fail, you try something new, and you learn new skills that you can apply for your personal life and your employers. So it's all beneficial.
And there's a lot involved there. So you're showcasing that not only do you know how to build code, deploy code, you know how to write documentation, you've built a community around it. There's you thought about the licensing. There's a lot we've discussed here. And that shows that you know more than just I go and sit and write code all day long. So, well, there's a whole management layer here, and you're thinking big picture. How do I want this all to unfold? So, Jared is thinking to you, Jared. You're looking to hire someone. You see they have a very interesting project on GitHub. That I'm assuming would that hold sway for you as well as you're evaluating. Oh, is this someone that we would want to hire on our team?
Yeah, and it goes back to one of the points you were making, Pierre. It's like, putting yourself in the user's shoes, because it can be easy as a developer to just be, so focused on, your own way of thinking and your own code, and that's it, and never thinking beyond yourself, but by going through the process of, creating an open source package and then showing that to the world, it sort of does force the issue of like, hey, how do I show this code to the world? Can I write good documentation, good, examples, good demos, good tests, and so, as you said, like as a resume, it is a great way to showcase your work and say, hey, no, I am I'm a full stack developer, a well-rounded developer. I'm not just going to write algorithms, but I can also write, documentation and help other developers, use my software, because it's like software development. It's very rarely just, one person in isolation. It's, your code's can be a part of you're a part of a team. It's your code's, developed and used in conjunction with other code, and how well can you fit that code together and communicate as a team. And so going through the process of documentation and open sourcing really does, demonstrate and flex a lot of those skills.
All right. So I want to make sure I make sure for time we conclude this. If someone wants to get going, I'm going to include links to OpenMVG so people can find it and they can read the documentation and everything. I'll have a direct link as well to your 10-year retrospect. I'm looking back to everything you've done. But just from you, Pierre, where would you be advice to someone who wants to get started using it? Where would they start? Just go to the GitHub and clone the repository and start having fun with it? Or you start reading the documentation through? How would someone get going with that?
Yeah, I think my advice is try to have fun. So try to understand what you want to learn. Do you want to learn about how to run a pipeline? Do you want to understand which algorithm are running? Do you want to just try to hack the code, modify something quickly? Do you want to contribute back? So try to identify existing issue, try to find if you can fix something. So I think open source is about having fun. So just try to identify what you want to do, what you want to learn, and just try to understand where you can help. And there is no reason, don't be shy, just go ourselves, ask questions, say you want to help, and people will gladly receive your feedback and try to do better, or just try to take you along the journey and just share something as a community.
Mm-hmm. That's good advice to ask questions on the boards or the discussions. I am not a software programmer. I am not an engineer, and I will sometimes try some project that's out there. It's like, okay, I think I can get this to work. Run into a roadblock that is very simple. Any of you guys probably would just not even realize that's a problem. And I'll ask questions, and people so gracious to answer my questions, even if they're as simple as you just didn't know you use the command prompt line right.
And if something you notice on GitHub, for example, there is issues and now there is discussion. So somehow a GitHub organization notice that there is a place where you just need to discuss about open questions, see if the question was answered, a kind of FAQ somehow. And there is a part where people just say, I want to speak about code, I want to speak about issue in the code. And it's showing that there is two communities there. So one of them is about coding and the other one is about using the project or try to understand the knowledge of it.
That's good. All right. Anything you want to add to this, Jared? Would you have any? I don't know if you've actually built or maintained any projects, but for anyone else before we close, any aspiring people from your computer vision background, is this something that you would tell them to go look at if they're trying to build something at work or personal project?
Yeah, the amount of open source code that I've actually contributed to is very small. During my PhD work, all of the projects that I had done as part of my PhD, I made sure to release that on GitHub, but that wasn't, and there was a few, bug reports and, issues that I had fixed afterward, but not very actively maintained. But it comes back to this, just, building upon the work of others. The open source community and the open source code, it is really important to be able to not have to re-implement a structure from motion, not have to implement a 3D reconstruction pipeline from scratch every time, or being able to, reuse modules and modify them and contribute those modifications back to the community ends up being really important. And so a lot of the software we write, are built upon open source libraries. Like you mentioned, OpenCV. OpenCV in itself has a lot of computer vision components in it. And it's got some, 3D reconstruction, pieces, but it's not a full 3D reconstruction package, and so that's where it's, using, open source code inside of other open source projects to then build other tools, just ends up, enabling a lot of, new research and new engineering.
Yeah. And I think you made a nice point about there is building from scratch, and it could be, I need to start from zero for a good reason. And I understood this reason because I look around or I tried other project, or now I know, I can use this brick. It's really going to empower me to go to the next level. And it's very important to have this pause about, let me evaluate this and understand the scope and context. And after I can go next. Don't go too fast. You just take your time and you're going to be happy about it later.
All right. Well, that's a good point to end on. So Pierre, where can people find you if they want to connect with you? Are you on LinkedIn, Twitter, any other platforms?
Yeah, you can find me on LinkedIn. I'm always open for questions on GitHub. So just
okay. And then of course we can always follow your work through GitHub and on your discussion board and questions as well. I'm assuming you're still very active in there. And Jared, of course, we can find you and I on LinkedIn and Twitter. But so thank you very much for your time, Pierre. And I hope people go out there and give this project a try, either to use the code, fix something they might see a problem in, or just jump in the discussions and talk about computer vision here. So thank you for coming, and I'll see you guys in the next episode.
Thank you very much for inviting me and being able to speak openly about open source.
Absolutely. Thanks, Pierre. Thanks.
Yeah. Thanks, Pierre. Well, there you have it. I hope you learned something about creating an open source project and maintaining it for long term. And I'll ensure I link all of the documentation for OpenMVG in the show notes. And if you like this podcast or on YouTube, please subscribe to our channel. It means so much to us and letting us know we're providing content that's relevant to you. I'll see you in the next episode.